This is a video for AQA Mechanics Work, Energy and Power section 1.5. We're looking at conservation of energy. In the last video we saw that if we dropped an object and there's no external forces acting on it, so only its weight, then the conservation of mechanical energy was found to be such that the gravitational energy that's lost is equal to the gain in the kinetic energy as it falls. So we can say therefore that final mechanical energy is equal to the initial mechanical energy. And we can use this principle rather than using equations of motion to solve problems. So as an example of that, just consider this a 0.3 kilogram mass falling 4 meters. The change in the potential energy, so the change in gravitational potential energy, is equal to mgh. So that's 0.3 multiplied by the acceleration due to gravity 9.8 multiplied by the height 4, and that gives us 11.76 joules. Now instead of using the equations of motion to calculate the speed of the ball at the bottom, we can say that that potential energy is converted completely into kinetic energy, and therefore we can say that the kinetic energy, 1/2 mv squared, at the bottom must be equal to 11.76, and that gives us v squared is 78.4 and v is 8.85 meters per second. So that was an example where there was only gravity doing the work, and we can say that mechanical energy is conserved. However, if there are other forces, then we have to change this slightly to say that the final mechanical energy is the initial plus the work done. Or, turning that around, work done is final mechanical energy minus initial mechanical energy, or just that the work done is the change in the mechanical energy. And we're going to use this idea in a second example. So here we have a skier that's going 20 meters down a slope which is inclined at 30 degrees to the horizontal, and we want to find her speed at the bottom of the slope. We're told that the slope is smooth. So in other words, we're ignoring any frictional forces that there might be on the slope, and we're also ignoring any air resistance. So firstly, h will be equal to 20 sine 30, and that's equal to 10 meters. So the height that she falls, vertical height that she falls, is 10 meters. So that the gain in the kinetic energy at the bottom, 1/2 mv squared, at the bottom will be equal to mgh at the top, and we can therefore see that that cancels out, the m's cancel, and v squared is 2gh. If we substitute the values into that, we get that v squared is equal to 20 multiplied by g, which is 196, and therefore v is the square root of 196, which is 14 meters per second. So at the bottom of the slope, the skier is moving at 14 meters per second. Now in the second part of the question, she then moves on to a flat part of the course, which is then rough. So she's starting off now at 14 meters per second, but there's a frictional force acting against the motion of 0.25 mg newtons. And eventually she comes to a stop with that constant force having acted. So we can then say that the work done by the force, so the work done by the frictional force, is equal to the change in the energy which is obviously just the kinetic energy, and the work done by the frictional forces, so that's negative 0.25 mg multiplied by the distance moved d, and the change in the kinetic energy, the final kinetic energy is 0, and then minus the initial kinetic energy, half mv squared, and that would be equal to negative of 1/2 m multiplied by 196, or 98 m, which of course was negative 10 mg. You could look back at the first part of the question to see that it was negative 10 mg when we calculated the kinetic energy. Therefore, d is equal to 10 divided by 0.25, so d is equal to 10 over 0.25, which is 40 meters. And that's the end of this video on conservation of energy, and in the next video we'll be looking at the work done by a variable force.